Welcome back to the course LTE System Overview. Now we will talk about the frame structure in LTE. We already saw in earlier chapters that we have two different duplex methods that can be used for LTE. One is frequency division duplex, the other one is time division duplex. The two different duplex methods result in different frame structures. So first of all, we will see the frame structure for frequency division duplex. In LTE, we have so-called radio frames that are 10 milliseconds in length. The radio frames are then divided into 10 subframes of 1 millisecond length. The subframe itself is divided into two time slots of half a millisecond. So, when we are talking about LTE, we usually are not talking about those time slots, but of the subframes, because one eNote B will always schedule the whole subframe, so the whole millisecond. This is also called the scheduling interval. The scheduling interval in LTE is 1 millisecond. Those times, this frame structure, is based on the so-called basic time, TS, which is something around 32 nanoseconds and has some historical reasons to maintain the interoperability between LTE and UMTS. So one time slot is defined as 15,360 times this basic time. This makes half a millisecond. One radio frame is defined as 307,200 times this basic time, and this makes up 10 milliseconds. In the case of time division duplex, we maintain the same structure of radio frames with 10 milliseconds and subframes with 1 millisecond. But whenever we switch from downlink to uplink, we have to insert a special subframe. The special subframe is made up of a downlink pilot time slot, a guard period, and an uplink pilot time slot. This is necessary because we have some time delays we will see in a later slide, and therefore we have to include this guard period. When we talked about time division duplex, we already mentioned that this is a very flexible system depending on our traffic model. So when we are configuring our TDD system, we have different configurations available to have a flexible system in the sense of downlink and uplink time slots or subframes. Here, for example, we see that configuration 0 is made up of 2 downlink and 6 uplink subframes per radio frame. We also have 2 special subframes because we switch from downlink to uplink every 5 milliseconds. Further, we have also configurations available where we switch every 10 milliseconds, and they are different in the number of uplink and downlink subframes. So far for the general frame structure in LTE. Thank you for watching.